Hi, good morning, folks. I see lots of people coming in and joining us. Well, I should say good morning from Oklahoma City and good afternoon to the folks out on the East Coast. Thanks everybody for joining us. I'm joined by Jake Beam and Mike Mills from Ranke. We're really excited to get started. We'll start in just a couple minutes, but if everybody wants to let us know, I have two questions actually today. If you've been on our webinars, would love to know where everyone's joining us, and I would also love to know if this is your second or third or how many webinars you've joined us for in the past couple of weeks. So if this is not your first, love to know that as well. Jake, what's the weather up there in Nebraska like today?
Oh, it's changed quite a bit in the last week. We went from 70s and perfect fall harvest conditions to wet, and now it's about 40, 45 degrees and wind 20, 30 mile an hour. So
Yeah, we
definitely a
had
change.
we had that same exact thing yesterday. We were sustained 25, 30 and gusting up to 50. It was brutal. And I woke up, it was 36 this morning here in Oklahoma City. So a little frost on the tomatoes, unfortunately. But we got a really nice second spring. You guys do a garden up there or anything?
My in-laws who live pretty close to us, they do. And but we pulled tomatoes out a while back. We were very, very fortunate with tomatoes this year. So
Really? It's so interesting. The beginning of the spring, we had maybe a handful, and then summer was just not very productive. And then the second spring, dozens,
yeah,
dozens. So
yeah.
Jake, your garden's 160 acres and it's all corn.
Yeah, I literally have a new Ranke E3 machine that pulls up, and the end gun waters the east side of my yard. So
Wow, that's fascinating.
yeah,
Let's see, seeing folks from coast to coast here, and Jim, nice to see you from Oklahoma. Oh, and third
You got
webinar.
some
Wow.
Canadians and some Austria here, I see.
Ooh, global representation. We love that.
well, I know one of our good friends, Josh Mosier, started to push, shared a lot of this with some of his coworkers. So I'm assuming that's where that link's coming from.
Wow, fabulous. Well, thank you for joining us. Whether you're here close by or across the world, we're certainly glad you're here. And with that, we'll go ahead and get started. My name is Luke Reynolds. I'm the Associate Director of Government and Public Affairs for the Irrigation Association. I'm joined by Jake Beam and Mike Mills from Ranke, and we're going to be talking a little bit about center pivot uniformity and really just anything that Jake wants to talk about. You can talk about dreams, hopes, everything. This webinar is eligible for one CEU. We just remind everyone that in order for you to be eligible to earn that CEU, you do need to stay for the entire time. We welcome everyone to ask questions throughout the webinar. We'll stop the webinar and I'll be rude and interrupt Jake so he can answer and answer any questions that come up. But again, we're just really excited you're here, and thanks for joining us. And with that, Jake, I'd love to turn it over to you.
Okay, wonderful. Thank you. As Luke said, Jake Beam with Ranke Manufacturing. I have been with Ranke Manufacturing for 20 plus years, based here in South Central Nebraska. I grew up in North Central Kansas where we didn't have a lot of irrigation. So it's a little interesting that this is the world that I've lived in for the last 20 years. Also have Mike Mills here with us. Mike is from North Carolina. Mike is going to be our expert when it comes to everything. I mean, not only is Mike with Ranke Manufacturing, I don't take that away from you, Mike, but Mike is going to be the expert if you guys have questions on golf course management, landscape stuff. Mike has a lot more credentials when it comes to that stuff. So towards the end, when we have questions, even if it comes up, you have landscape questions, Mike should be able to help us out on some of those as well. So, Mike, anything else to add before we get started?
I've got 17 years at Ranke Manufacturing. I'm a certified designer, residential, commercial, golf, and ag, certified contractor, and an instructor for the IA. So that's a little about who I am. Thanks for letting me join you, Jake.
Yeah, you bet. Okay, I'll go ahead and get started. Mike, can you see that screen?
Yep, you're looking good.
Okay, perfect. All right, like I said, technical sales manager with Ranke Manufacturing. I do have a CID and a case certification For any of those who don't have a certification through the Irrigation Association, I would strongly suggest going down that path, especially if you just want to learn more, the reasons why we do things the way we do. It's such a good process that it'll really give you the foundation for basically everything we're getting ready to discuss here. So, with that, let's just go ahead and get started here. Mike, can you see my mouse on the screen? So if I
Yes,
just
I can.
perfect. All right, so we're going to talk strictly about center pivot uniformity on this webinar here. Like I said at the end, if you have questions for Mike, please feel free to ask him whatever you need to. What we're going to cover why uniformity matters. When we talk about uniformity, there's some terms that get interchanged sometimes, and a lot of times they don't mean the same thing. So we're going to cover that quite a bit. We'll cover how to test for uniformity. This goes from new systems all the way out to existing machines. We'll do some best practices and that kind of stuff. And then we'll do just a little bit at the end, how to identify uniformity issues. Some of these will be very obvious. Some of them may not be. Some of them may be grower caused issues too. So these are just kind of some things that we deal with on a day-to-day basis that we get phone calls about. So uniformity matters. When it comes to uniformity, there's a couple terms that we use, and like I said, they kind of get intermixed a lot, whether or not we're talking about coefficient uniformities or distribution uniformities. I'm going to spend quite a bit of time talking about the differences of those two terms to make sure we're all on the same page, because one is a very specific use case that we use when we're talking about irrigation scheduling. The other one is how well we can design machines from the very beginning. So uniformity, it's the state of being the same or lacking variation. So uniformity in general, that's just a very good blanket statement, right? We want to be the same across the board, or we try to lack variation. And so when we're talking about uniformity for a pivot, we're literally talking about how evenly we disperse the water across the field, or we lack variation, no matter if it's the first span or underneath an end gun, right? Those are all the different types, very big extremes of water application, but we want to make sure we're doing it the best we can. Now, when we talk about uniformity, there's going to be two different terms that we're going to talk about. We're going to talk about the CU and the DU. And that CU is that coefficient of uniformity, and the DU is the distribution distribution uniformity. And we will we'll cover what those two cover. And then we're going to talk a little bit about poor versus good. A lot of times, especially if there's any producers in this group, you will do if you do your own cup test, you may find out that there's some variation. Realistically, a little variation you can't stop, but I'll show you some cases where it's not it's not as bad as you think. So the coefficient of uniformity, it's going to be what we call the CU, and it's always displayed as a percentage. When you talk about the IA and some processes you can learn, this is one of those things that they try to keep separated, so we know whether we're looking at a CU or a DU. And the CU is the average deviation divided by the average catch. That's going to be the main things that we'll plug in there, and it's displayed as a percentage. Now, distribution uniformity, on the other hand, is the minimum infiltrated water versus the average. So it's displayed as a decimal. And the reason we display that as a decimal is it gets plugged into some other calculations further down the line when we're doing irrigation scheduling. So if you ever see a percentage, and I'm going to end up arguing myself out of this later, and I'll tell you why, but if you ever see it with the IA as a percentage, it's a CU. If it's a decimal, it's a DU. And those are the two different things there. Now the DU usually gets converted over to what we call the DU of the lower quarter, where it's got that little subscript of a LQ there. And it's that average lower quarter divided by the average infiltrated or applied. And it's still displayed as a decimal, but this is how we use, what we use when we're talking about irrigation scheduling. So a couple of differences here. The primary focus of the CU, it's the consistency of water application. So basically across the whole thing, how consistent are we about applying the water? The DEU, if you think about it, how adequately are we watering the driest spots, right? So those are the two differences there when we talk about these two different formulas. The actual calculations, when we're talking about a CU, the CU treats overwatering and underwatering the very same, right? And these are going to be big points that you will always hear guys talk about. The CUs, overwatering, underwatering, treated very equally, right? How well do we balance those and how well do we apply water? When we talk about the DU, especially the DULQ, it emphasizes the underwatered areas, right? Because we really want to know when we're talking about irrigation scheduling, what part of the field do we need to apply the most water to, or how do we adjust for those parts that we don't water as well? So that's that DULQ. And they're best used for, so think about when we use a CU versus a DU. A CU is basically a good way to evaluate the performance of the whole machine. And then the DU is, like I think I've said this a couple times now, it really is for that irrigation scheduling or runtime, right? That's when we're going to use these in different parts. So a high CU closer to 100% indicates very similar application rates across the whole collection of cups or cans. And a high DU indicates that minimum application area is receiving close to the minimum average. So it helps us be a lot more efficient. So when we talk efficiency with irrigation, that DULQ, the higher that can be, the more efficient we can use our water as we do our irrigation scheduling. Okay, any questions about those two differences? If so, you can put them in the chat, and we can stop and take a little time if anybody needs it. If not, we will keep on moving. Okay, we're talking about a DU, right? How good are we applying water across the whole area? This is going to be a type of an image you'll see a lot. That black dotted line is basically what we're going to call our application depth or our target application. And you can see with a good DU, this whole the whole root zone got enough adequate water because our DU is very high, right? So each plant is receiving significant or is not receiving significantly more or less. When we go to a poor DU, right? If I would use the exact same application rate or the depth, and you can see here on the left-hand side, there's some underwatered areas, and on the right, there's overwatered. So we put on the same volume of water, but some plants here you can see would be stressed, and some plants we went below the root zone, right? And that's what we usually consider leached water. Same volume of water got pumped, but we're not distributing it as evenly. And so now we have underwatered and overwatered areas of the field. Now, when it comes to scheduling, when I was talking about being more efficient, if we would schedule our irrigation events to make sure that those driest areas got enough water, you can see all the overwatered area now. And so when we talk about distribution uniformity and we have a low distribution uniformity, it really affects how efficient we can be when we're scheduling our irrigation. In this case, you can see that'd be all that leached off water, right? And you think about all those overhead costs that come along with inefficient or inefficient uses. You know, electricity, fossil fuels, leached out nitrogen or nutrients, right? Anything that can move with the water. Those are all those things that we don't get back, or we don't get to reuse just because of a poor uniformity issue. So here's a way we can test for uniformity. There's all sorts of ways to do it. There are some good ways to do it, and then there's also some poor ways to do it. Here you can see just some different images. The one on the left is some cup testing that we did a few years back for one of our new products, our ESAC. The middle picture, thanks to Josh Mosier and Coma Irrigation, he sent me that image. He did some testing down in, I think it was New Mexico or Arizona down in the Southwest. And he found these cups. You can get them on Amazon, and they come with the stands, and they got the measurement right there on the deal. Those are pretty inexpensive for a good test. Then the one on the right, that's on behalf of the Hunter Ag Group. This is their indoor test facility. So you can just see all these different versions. There are different ways you can test uniformity from even a styrofoam cup to a little bit higher end infield cup testing to what they do indoors to ensure that their products work correctly, right? So, but what we really want to do is we want to talk about how to test center pivot uniformity. Okay. I think this is number one. We're going to go through these step by step. There's going to be 5 steps. We're going to verify the existing sprinkler package of the system. We're going to set out our collector cans or cups. We're going to operate the system, and there's a couple things we should know about when we operate the system to make sure that there's that it's going to give us the right results we want. We're going to measure the water volume, and then we're going to enter the data into a spreadsheet. These seem very basic, and I want to take some time on the first 3 here to make sure that we do this the right way. So, like I said, number one, we're going to verify the existing sprinkler package. If you guys have never seen a sprinkler chart before, this is a Nelson sprinkler chart. And we're going to kind of go through some of the information on here. This is one of the most important things I think that if everybody wants a tip on to make a producer pay attention to this, that gauge pressure and total system flow, if they have a flow meter and a pressure gauge on their pivot, I would suggest, this is what I suggest to even the local growers around here, at least once a month while that pivot is running, make sure you write those pressures down and flows down if you have a flow sensor. If you start documenting those at least once a month and something happens out in the field, let's say it's late July and then all of a sudden your pressure drops 5 pounds from what it always ran at, it may be a telltale sign that there's something either going on with your pivot, your water table, the pump itself, all these different things that if you start seeing variations in these systems month after month, you can kind of head some of the stuff off. And if you catch it early enough, you can do some work out there and prevent crop loss if you catch it early enough. So, but that's where we're going to check this, right? We're going to make sure that the pressure, that the system's operating at the right pressure. We're going to make sure that it has the right amount of flow, if you can, if it has a flow meter. The other thing that we're going to do when we verify the existing sprinkler package, we're going to make sure that it's got the right regulators on it, according to the sprinkler chart. Here you can see it's got 10-pound regulators. And then on the other side, you're going to see that there's the right nozzles, right? So we want to make sure that throughout the life of this machine, that nothing has changed, that we're running the right regulators and the right nozzles in the right location. This is all before we do a cup test, okay? Now, if you would have noticed there, the cups or those nozzles there, they go increment up, right? I love this video because it shows these devices from left to right. The center pivot would be on the left, right? Because as we increment, we go farther out the field, we're gaining more and more ground we have to cover. The flow rates increase. So if you ever look down the system and you notice you don't have this gradual more water as it goes down the machine, there's probably something wrong with the sprinkler chart itself or the installation. So from the center point, moving out, you should go from less water delivered to more out on the end. So if you don't see that nice gradual water pattern getting heavier and heavier out on the end, or an anomaly in between, you probably got an issue of an installation.
That's also a telltale sign that the grower may have serviced his own machine, replaced a device, and was unaware of the nozzle sizes. That's very, very common.
And if another easy one, as people buy new machines or like this last late July around here, we had some very high winds. Spans get knocked down. They replace them with new systems, and guys will move these knockdown spans into corners, and they run the same sprinkler package on the corners that they should have been running as like in the middle spans out on the other machine. So, and they can mix and match these spans up. These are just, I really like this video because it shows a very, it's really aggressive how much more water is going out. But this is the way it should look all the way from the center point out to the end. It's a gradual increase in water flow. Okay, so once we've verified all that, we verified the pressure, we verified the flow, we verified the sprinkler chart on the machine, we're going to set out our collector cans or cups. Now, a couple things. Cup selection, I showed you some of those earlier. Here's a couple things you should do. Make for sure that they're all the same, right? That's the one thing we want to make sure is that all the cups are the same. That way they're all collecting the same area, right? They're getting the same opportunity to catch the rain or the water from the pivot as every other one. So if you have a bigger cup out here, it's gonna catch more water, right? If you have a smaller cup here, it's gonna catch less water. So you want to make sure all the cups are the same. You want to make at least one parallel line from the center pivot. So starting at the center point, you want to make one parallel line, or it runs the same direction right down the side of the machine, all the way out to the end. The cups, we don't want to space them more than 10 feet apart. Now, these are based off of some Asabi type recommendations and standard practices, no more than 10 feet apart, okay? And then the other thing too, is we want to make sure that it's uniform, right? The spacings need to stay the same from here all the way to the end. And if you run across a wheel track or anything like that, you can still put the cup offset, right? If you're going every 10 feet and you happen to hit a wheel track, you can offset it, but just make sure when you're making your, when you're recording your data, you're not actually using that data in it, or you document it that, you know, it could be an anomaly because of where the placement was. It wasn't uniform with everything else. Okay, so you're gonna set them out. Now I said make one parallel line. Here's that same cup test we did for a swing arm. I just want to show you guys kind of how complicated this can get, or it can be very simple. But you can see all these cups are the same cups. They're getting the same opportunity. They're spaced evenly apart. One thing to notice, if a cup gets tipped over or it's angled, keep that in mind that could alter your results as well.
You'll notice in that picture there was one cup that was altered for that wheel track as well on the left-hand side. And
Yeah,
that's what
both of
Jake
those
was
you can
talking
see
about.
on each side. Yep, you can see on each side of that wheel track that there's a cup that's not in that same line. Yep. So when we did our swing arm testing, we actually threw those results out. So we just left them out there just to see what was in them, though.
Jake, we have a question. It says, how much angle is tolerable between beyond dead level? So how much angle can we tolerate on a cup before we have an issue?
Um, that's going to be a judgment call. And the reason why I say it's going to be a judgment call is because every testing environment, especially real world testing, is going to have lots of different effects, right? The biggest one is going to be wind. So when we were doing this testing here on this video, we were operating the swing arm between like 3 a.m. and 6 a.m. in the summer because that was our lowest wind opportunities. And you just have to make those judgment calls, right? Because a lot of these things are going to be either like these are styrofoam cups and they're in a wire ring, right? And so even as depending on what type of a device you have, if it's a stream device and it hits that cup and it shifts it a little bit, right? All these things are just gonna have to be somewhat judgment calls. But if you feel that there was a cup that didn't have the same opportunity, or there was a cup that got disrupted out there and may have lost some of that water content, it's just one of those things you need to make sure we note or even make that decision whether or not you're going to throw that result out.
And keep in mind, these cups are rather lightweight, so a good strong wind can carry the cup away beyond just altering your application pattern. But you can lose some or many cups in a good wind. So that's why it's important to find a still a time as possible.
Yep. Mike, do you have anything else to add on about level of the cup?
No, that I think you covered it well.
Okay. Okay, now we're going to operate the system. Now, one thing everybody should be aware of when you're operating systems is that as the advancement of irrigation scheduling and the way we operate pivots anymore, there's a lot of sector programming, VRI type systems out there where these things may be changing the amount they're applying, either in a radial part of the field, right? It speeds up or slows down in different parts of the field, or even valves are turning on and off. So make sure all that stuff is off. But that way there's no changing of speeds of the machine or anything else. And it wouldn't affect any variability in your results. So,
Jake, I need to stop you. We had one last question
oh yeah,
regarding spacing that popped
yep.
up right at the end. Jonathan asks, should the distance between the cups be the same as the drop spacings? I know what I think. I'll let you answer and we'll see if we agree.
All right. Should it be the same as the drop spacings? I'm going to say no. And the reason why is because, well, I'm gonna say no, and I'm gonna argue with myself a little bit in my head. It depends. How's that? These drops, it depends on if you're in southern Texas and your drops and you're running a spray type device that doesn't have a lot of throw, you need to take that into account. If you're running in this pivot that's out my window right here and you've got devices up on top, you can probably space things out because you're going to get that overlap between devices get farther and farther, right? So you just want to make sure you're giving each cup the same opportunity. And that's going to be depending on your sprinkler height and the throw radius, you may have to shorten those cup spacings in if you don't have as far of a throw.
So my thought is kind of like Jake's, it depends. In my opinion, we're going to start out on a center pivot generally with rather large spacing already beyond 10 feet, and our spacing is going to change as we go down the machine. So we don't want to change our cup spacing as we go down the machine. And secondly, as Jake also pointed out, those devices work together in tandem. So if you're placing the cups underneath the drops, you may not be getting the full benefit of the overlap, and you may be getting some extra if your device happens to have a little drool. So just keep that in mind on a center pivot. On a lateral move, your drop spacing is a good way to do that as long as it's less than 10 feet. But I would not put them under the device. I would split the difference between devices so that you get your proper overlap.
Yeah, very good. I'm glad you brought up the lateral one. Okay, when we go to operate the system, Mike, let me make sure there's no other questions.
None that have popped up from that last one, but that was a good question.
Actually, I'm going to stop you right there. And Mike, thanks for jumping in, and thanks to our two folks for our questions. We actually do have another question that came through the Q&A. Mahmoud asks, should we make a cup line replicate or have them replicate, I assume?
It depends on what you're testing for and what you're trying to get out of your results. If you're just trying to test an existing machine, usually a one-time test will give you pretty good results or at least good feedback of what your system's doing. If you're trying to do any more testing than that, let's say you're trying, in our case, we're trying to test our new style swing arm and the watering pattern that came out of it. We replicated that over and over. We had a grid pattern line out there. We actually ran over that same part of the field multiple times. So yes, but it just depends on what type of testing you're trying to do and what you're trying to get answers for.
I think it depends on your condition as well. If you have a wind condition and you just can't get to dead still, then you're going to want to replicate those on probably 45-degree angles, and then compare your three numbers to see how much effect the wind is having on drift.
And another one on top of that too, Mike, I'm going to add on that. A lot of machines have two nozzle packages, right? So you have a high flow nozzle package and you'll have a low flow, and you'll actually change those nozzles out throughout the year. So if you want to check uniformity on one, you better be able to replicate it and check the same on the other nozzle package as well. Okay. All right. We will move on to how to operate the system. Now this may seem very simple, but you got to think about this before we start the system. We want to make sure the inside cups or the cups closest to the center point are outside the watering pattern before we start. So if you got devices that throw water a long ways, you need to give that cup the opportunity to catch water that whole process as that thing comes across it, right? So if you have a really high throw pattern or wide throw pattern, you may have to start that machine quite a ways away from the very outside cup. And we got to run water that whole time. We're going to run the system over all cups until the inside spans are no longer receiving the water, right? So not only do we have to start it outside that pattern, but we have to allow it to go all the way across as well. Okay, now we're going to measure the water volume. Now, the biggest thing with this, use the same measuring methods on all the cups, right? If you're going to, one of my least favorite things to do is to have the conversation with the grower and explain to him why rain gauges are probably not the best way to just do a cup test. Yes, it probably gives you a little bit of an insight of what's going on out there, but every rain gauge, I mean, everybody knows the local grower that has 4 rain gauges at home. And when he goes to coffee in the morning, he's going to use one that says inch 20, not the rain gauge that says 3/4 of an inch, right? That's just a different disparity of different rain gauges. So when you're doing this, we make sure we use the same measuring methods on all cups. So if you're using a beaker, if you're using those cups that that I showed earlier, you can get that already have it in there. Let's make sure we're using the same measuring methods on all of them all the time. I think we covered this a couple times. We want to make sure we throw out any damaged or spilled cups, right? And I'm not saying you throw the whole thing out, right? But you just throw out those data points, right? Or you asterisk them somehow, however you're collecting your data. You want to make sure that you throw out those data points if there's anything like that out there. And then number 5, we're going to record the data and enter it into a spreadsheet. There's lots of universities out there that have spreadsheets already built up that you can just download for free and then put in all this in there. So if you're looking for a spreadsheet, any major university that has a good ag program will probably have one that you can get, or reach out to your local extension office, and I'm sure they'd be able to help you out. So I'm going to go back to some of these formulas. I want to make sure everybody understands what these things are and what they do. We're going to talk first about the coefficient uniformity. If you've never heard of average deviation versus average catch, I'm going to just kind of show you guys here a little very basic image of how this works, right? Now that we've talked about how to do it, let's put one to work here. Here's a ranking machine. Just by the way, it's watering. You can tell it's got pretty good uniformity out there. But let's just say we want to do a cup test on this. Now, I know that I said, at least 10 feet. This is going to be a very raw version of this, right? So we're going to take our cups over here on the left-hand side, and we're going to disperse them up and down this machine, right? So now this one is technically, you've only got 1 cup there, right? But we're going to go 1 cup per span, and we're going to walk this machine until it goes all the way across it. Now, keep in mind, see that cup that's at the top of the picture there will clear back towards the center point. If I would have just started this machine, technically that cup's already getting water in it, right? So you would actually have to run the machine back a little bit and start it earlier and then allow it to walk through all these cups. So if it was a perfectly dry field like this, when you start your machine, all the dry stuff should be outside of the reach of the cups when we start. And then we walk over them. So let's take a look at the data of these ones. So here's my 8 cups. And here's all my measurements I got out of all these 8 cups. And if you add these all up, the average is going to be 0.8 inches. So that red line is our average line. Okay, so the deviation is just the difference from the average. So when we're talking about deviation, the deviation is just how far off of that red line are we? It doesn't matter if we're above or below. It's just how far off there are we. So you can see on that far left one, we're 0.05 inches off. And in the middle ones, we're 0.06 inches off, but one's below, one's above. Okay. So the average deviation, you add all those up and you come up and the average deviation is 0.0275. So in this instance, even though there's some variability in all 8 of these cups, if you would plug all this into that same CU formula, we come up with 96.6% CU. That's a pretty good uniformity measurement for a machine out there in the world. So that's just basically how that CU works, right? So it doesn't matter if we're above or if we're below, we come to the point to where we're 96.6% CU. So now we talked about the DU, right? And when the LQ, we're going to talk about how we're going to treat the overwater or the underwatering differently. So that same set of cups, right? There's our average line, the 0.8 inches. I'm going to find the 2, in this case, the lower quarter, right? The bottom 25%. It's going to be those 2 cups right there, a 0.75 and a 0.77. Now my average between those two is a 0.76. So if we plug all this in, my DULQ comes out to a 0.95. So this is what we would use when we're doing irrigation scheduling. We know that our DULQ is 0.95, and basically it's going to say, hey, those underwatered cups, how much more water do we have to put on to make sure that they get the right amount? So I don't know if anybody's ever, wondered about how those formulas work, but that's the very easiest version of it, right? We're going to talk, you know, most pivots out there will have over 100 cups on them, not just 8. So.
So one of the things that CU does, and the reason we can't use it for scheduling, is because it attributes overwatering and underwatering the same. CU assumes that the overwatering will move to the underwatered area, and they will cancel each other out. So that percentage just shows the area that can't be canceled out, as opposed to DULQ, which tells us how much extra we have to put on to make sure the driest area gets wet.
Absolutely correct. Okay, so that's basically the information you would get back if you did a cup test. Okay, so then I'm sure the question will come out, what's acceptable, right? Well, when we start talking about this and we do all these cup tests, you can see out here with all these people out here, just so everybody knows, a lot of these guys you're seeing in these images when we did our swing arm test, those are all engineers. So you can just imagine the overhead cost we have by doing these cup tests out there and making sure things are done the right way. It can be pretty expensive, so and labor intensive. So back in 2003, the NRCS adopted what's known as a CPED. And a CPED is going to be a virtual version of doing what we just talked about, these cup testing, okay? And it's all done by software. This one, the lady that works here at Rankin Manufacturing, she's designing a sprinkler chart there. And basically off of the sprinkler chart, we can basically do a virtual cup test. And it looks something like this. This is a CPED. Okay, I blocked out the grower's name here. This is a real life system. But if you look at those blue dotted lines, that's basically like the same thing as our cup levels. How much water, if we ran this machine, did each one of these get? Okay, and that's going to be that top section there. So the flatter that line is, the better off we are as far as uniformity. Then if you look down here in the bottom left-hand side, it's going to give us those same things. Now, I said earlier that DU is always in a decimal. Well, our government, obviously the US government, we can't all agree on anything. So they're going to be the ones who put it in not a decimal form. Okay, so if you needed to use this for irrigation scheduling, that's going to actually be a 0.993, not a 99.3. But you can see here that it gives you that the CU and the DULQ, and that's all based off of these schedules. Now, like I said, this is a real life system, a 99.6% CU and a 99.3 DU. Those are amazing results. So any grower that's on here or anything like that, I would highly recommend when you purchase a new pivot or a new sprinkler package, you can request these from your dealership. You should know what these numbers are because it really affects how we do things out in the field. Yeah, go ahead, Luke.
I was going to say, Jake, let me just pause you. There's a couple of questions that we'll get to after in a couple of slides. So those of you that posted questions, I see them. We'll get to them in just a minute.
Mike, you're on it. You're doing it for me. I love it. I love it. Mr. Beam, back to you.
All right, good. All right, so like I said, these are all just software generated virtual cup testing that we can do based off of a sprinkler chart, based off your devices, pressures, flows, all that kind of stuff. So, all right, so here's the fun part. What to look for and how to fix it. The how to fix it is always complicated. There is never an easy answer for uniformity issues because it can range from you have to replace it could be a pump issue. It could be like we discussed earlier, moving a span that got wrecked and we put it over here and the sprinkler chart was never changed. It could be improper installation. There's always something that can be going through here. So I just want to show you guys a few things that obviously you can look at out there. Always things to look for. Pressure changes. If the pressure changes at the center point, over time, right, it is a huge red flag, something to look for. And if you can't see it, I mean, I know these machines are huge and it depends on what you're growing, if you can even see the whole system at any point in time. But if the pressure is changing at the center point, over time, we need to start having some discussions. Same thing with flow changes. If you have a flow meter, now keep in mind these machines are overly complicated sometimes, and we've got swing arms and end guns, second end guns, VRI, wrap spans. There's all these different things that we can do out in the field that may change the pressure and flow at any point in time in the field. So when you're watching these things, make sure it's always, you know, in the same type of situation. If I turn my end gun on, my flow rates are going to go up, my center point pressure is going to go down if I don't have a VFD, right? There's all these different things that we just need to make out or watch out for. So crop and soil differences. There's all sorts of things out there that we need to take into account when we're making changes or when we're designing. And I'll kind of show some of that out here. And then obviously leaks. There'll be a video I'll share on here that I'm sure everybody will be able to pick out what's wrong, but I like to show this video because sometimes the stigma is as long as it's putting water on, I'm still okay and I'll fix it at the end of the year. Well, a lot of times if we can get it fixed early on, then we fix uniformity issues. We don't leach the nit or all of our fertilizers and we get much more even production. Then there's some mechanical issues. I'll show you a couple of images of some things to look at that are mechanical issues. And we'll kind of go through these one by one. Or plug devices.
All right, Jake,
Yep.
I'm going to stop you. If we can go back to that one real quick. I got a comment and then we got a few questions.
Okay.
So on the what to look for, how to fix, some of these things you're going to want to fix before you even start. So when you look at that picture, at that running pivot before you even do it, if you see obvious issues such as a leak or a nozzle or something like that, do yourself a favor and go ahead and fix those with a quick fix, because you know your excuse me, your data is going to be incorrect with those. So the obvious things you'll fix before you even do a cup test, unless there's a specific reason not to, that might be site or region specific, but you're going to want to set that up. So that's my comment on that. Jake, I'm going to pose these questions to you. The first one, Ariana asks, logistically, how many people do you have helping or participating in a pivot uniformity test in the field?
I will go back to that always changes, right? It depends on who you are and what you're trying to accomplish. If you are just let's say you're a grower and you're trying to check your own, you can do it by yourself. A lot of the machines in this part of the world have you know some type of a pivot road or something like that where it's always got open area that you could set these things. You could set up a cup test in between irrigation cycles early on, all that type of stuff. If you're trying to do a very in-depth cup test and you're trying to mitigate interrupting a grower, like in our case, we were actually out on a grower's field with that swing arm. Every morning we had 5 guys out there. Was it 5 or 6? I think there were 6. 2 teams or 3 teams of 2. One guy would read, one guy would document, right? So at least 2 usually helps because then one guy can run the measurement device and dump cups while the other one documents. So it just depends on how fast you get it done or how fast you need to get it done and your amount of help. So I know it's not the perfect answer, Ariana, but I hope that helps.
So the second question is from Yusuf. He asks, how does elevation differences affect uniformity measurements?
Once again, it depends. And what it's going to depend on is whether or not the devices are pressure regulated. If they are not pressure regulated, then the amount of pressure on those nozzles will fluctuate as you go up and down elevation. And as we all know, the more pressure we have, the more flow comes out of any size specific orifice. And the less pressure, the less amount of flow. So yeah, if those are not pressure regulated devices, you will definitely see a major issue with elevation. Now, on the other hand, if it's a sprinkler package that's, you know, 10, 15, 20 years old, and if you do a cup test up on the top side of a hill and you notice you don't get as much water on the top side as you do on the bottom side, then maybe it's time that sprinkler chart or that sprinkler package needs to be replaced. And it's the regulators themselves that are starting to fail over time, right? That those pressure regulators are not meant to last forever. So when you change a sprinkler package, please don't let a customer or as a grower, if you guys are on here, please think about the fact that regulator's got a spring in there And over time, that thing is working all the time, right? And then that spring will eventually end up giving out. The orifices in there will eventually wear, even with really clean water. So when we replace sprinkler packages, we need to make sure the regulators go too.
Jake, their next question is that have popped up here. Well, first of all, let me offer a comment on that too. For the high and low, if you do have a rolling field, you may want to do two lines of cups, one when you're at the highest and one when you're at the lowest, and take a look at what your deviation is so that you can that'll give you an idea of what you get. But for those of you that are looking to sell one, that's a great way to sell those. As Jake said, those pressure regulators can oftentimes fix those issues with elevation. So Ernest asked, is there a duration time span the uniformity cap has to be done to have the correct figures? So I'll take that real quick. As long as you start with no water in the cup and you let the machine walk through past the cups until there's no more water entering the cup. If you run it at 50% versus 100%, shouldn't make a difference because your deviations are going to be the same.
Agree. Very well said.
And we're on short on time, so I'm going to pick these up here. James asks, what field measured CU do you consider good enough? We don't see CUs anywhere near the values you're talking. The NRCS requires 88% in order for funding. As a CID, I didn't stamp anything that was less than 90. And I get nervous if I see less than 92, 93 for a well-designed center pivot. If you're looking at a solid set type of a situation, you're going to see those down into the 70s at best. And that one would have a whole different set of parameters if you're looking for funding on that. A question from Zachary. Can you explain more on why rain gauges aren't a good device to test with? Is the opening too small for an accurate reading? I think Jake was referring to multiple different rain gauges. You get one from the feed store, one from Rinky, one from somebody else, and they're all going to be a little bit different. So if you're going to use rain gauges, then make sure that they are all identical. Uh,
Well, and the other thing I'll add on to that, Mike, you think about the size, the opening orifice of a rain gauge. I think I read somewhere that, most universities suggest a diameter of, I think it was 3 inches. Use like the minimum diameter of the opening should be 3 inches. I'm trying to, I don't hold me to the fire on that one.
yeah, I
I
don't.
just
I
don't.
think I read or heard that somewhere too, but I don't remember.
So you think
Uh,
about, if they're saying it needs a minimum of 3 inch opening, and then we put a rain gauge out there that's a 1/4 inch, right? Depending on the sprinkler device, whether or not a raindrop gets into that, or a water drop gets into there or not, it could be all over the place.
Mahmood asks for cup positioning are all equal in distance, or do we make it narrower as we go outside from the center? They should all be uniform distance the entire length of the machine.
Yep,
Because as your machine goes out, those sprinkler devices are covering larger areas. So you have to have more water in order to maintain that uniformity with the inside.
yep. So
Um,
maintain those spacings. Yep.
Daniel asks, how do you compensate for evaporation from the cups during the test and measuring the catch?
Here, let me take that one, Mike.
Have
That
at
that's
it.
one of the reasons why we had 6 people out there dumping those cups, is because we were out there right at the break of dawn. And we were trying to measure those cups as quickly as we could before any wind or sun was on there. So ultimately, as long as you are, it always depends on what you're trying to test, and what answers you're trying to get. If you're just checking the general uniformity of a machine, just because you want to know, the amount of evaporation may not be that important to you, right? Unless you are in the Southwest and in an arid region, right? But you can measure those cups as long as, like what Mike was saying, as long as each cup gets full opportunity of the amount of water going in there. As long as that end one's done, you can start working your way back in towards the center point, right? And then as long as every cup gets the equal opportunity to collect the water.
And we've got Randy asks, do you model the first tower and end gun?
No on in guns, and when you run CPEDs for NRCS, I think it's 10%. 10% of the entire length of the machine you can eliminate from those CPED reports.
And then finally, Sadiq asked about getting copies of the slide deck. I believe the Irrigation Association is going to make this available once it's completed.
Yeah, we're happy to share these slides as long as Jake, this is your work, so we're happy if you're happy to
Yeah.
share those. And if anyone has any questions, I'll drop my email in the chat. But please feel free to reach out to me, and I can hand these off directly. So thanks for all these questions, and Mike, thanks for emceeing. These are some really great questions.
Okay.
Really
Yep, really,
appreciate that.
really good.
Yeah,
So
really.
All right. So
we got a few more slides to go
yeah,
there. So
this will be the fun stuff. Some of the stuff will get chuckles out of some, and then some people may make cringe. So let's talk just a little bit about some of these images, right? So when we're looking at like how to identify issues, I think everybody would agree that this aerial image here, that there's some issues out in the field. Okay. But what stands out? Most of the time, I'm gonna say most of the time, because there's never any one easy, golden bullet, silver bullet that fixes all. But most of the time, circle shapes tend to be sprinkler issues, right? When you see perfect circles out in the field like this underneath the main machine, that you may see some waves, you may see something like that. They tend to be sprinkler issues, not mechanical or anything else. It's built into the sprinkler package. You need to look into that.
could be pressure regulators too. Pressure regulators would be considered a sprinkler issue.
Absolutely. Other ones, I like this video because everybody's seen those little geysers driving down the interstate, and it makes me cringe. You can see that they're in the center of that span. It looks like a gasket's leaking. These are impact sprinklers. And as we get farther out on this machine, you're going to see some more leaks, some bigger leaks. And then you're going to see some impacts that aren't operating like they're supposed to because they just don't have enough pressure. And then you're going to see the end gun out here towards the end. Now the end gun, right? The end gun has minimum pressure requirements that it needs to operate on. And when we get out here, you'll see that it's definitely doesn't have enough pressure, right? So on this old machine here, right? This is definitely something that that it needs to be addressed. So you think about these impacts and the way they're supposed to be running. You can see some of them there that weren't even turning. So that means that they're not evenly distributing even its own water. That end gun there, I'm pretty sure that is about as non-uniform as you can get. And so this system right here, I know everybody would really like to wait until the end of the year and then we'll fix it. But you got to think about how much of an investment we spent on the system to begin with, and then some things like this we let go and don't address right away. So I think everybody could probably pick out a lot of issues there. But let's say that this was corn on rolling hills. You may not be able to see this whole system, but up to the top there, you're going to see pump pressure, right? You would notice this on the pressure if you would document this every month. Eventually, you would notice that the pressure starts to drop off on this thing at the center point because the flow keeps increasing because we're having all these leaks because we just cannot maintain the pressure at the center point. So there's some of those telltale signs. This one's not as easy. You can definitely tell that there's something wrong. You can see it looks like the wind's blowing. It looks like a Kansas wheat field in the summertime. It's blowing. It's actually not. It's actually a cornfield, and you can see all those strips through there. Well, I don't know. Like I said, circle shapes tend to be sprinkler issues. If you look real closely, you can see these are all on drops. And basically what happened is it was improperly designed. We exceeded the sprinkler spacing issues, or it was down in the drops and the plant interception was causing the water not to distribute right. So all these types of things can usually be addressed early on, but we don't ever want things to get to this point of the season. So one thing, if you are a dealer, if you're a grower, just keep in mind, if you have drops and you decide to change your crop type and you get up into that throw pattern of that device, plant interception will cause you lots and lots of problems if it wasn't designed properly. Okay, and then here's a different one. This is not a circular issue. You can actually see these little triangles out here. That triangle looks much a darker green than on the sides there. Wedge shapes tend to be mechanical issues, or there's something wrong with the system itself, not so much with the sprinkler chart or the sprinklers themselves. Um, I'll try to keep this kind of sped up here, Mike. I know we're getting real close on time. So this exact machine here, this one has you can see a swing arm down on the bottom. If you don't have swing arms in your part of the world, that span there extends out in the corners and it retracts up against the sides. We pick up a lot of acres with them. But what actually happened here is, Mike referenced it earlier, a little self-maintenance on this machine, and they replaced some tires and wheel gears and center drives, and the swing arm could not keep up with the parent machine. And it was actually slowing down the whole system whenever it was extending out. So it's actually overwatering in all those wedge shape areas because the swing arm could not keep up. And here's a fun one, last one. Here is here's some yield data. Like I said, wedge shapes tend to be pivot issues. If you look up in the top part of the field, that little wedge shape right there, you'll notice that the yield does not look as good as the rest of the field, right? We're always gonna have a little bit of variability depending on soil types and all that. But you can see that whole wedge shape there. Now, not everything when we talk about uniformity is always something that we think about, either sprinklers or mechanical issues. So this particular one, I want to show everybody, here's August 5th, okay? That top wedge there it's not there yet. There's August 15th. You can start to see a few red spots come up. It's now a lighter green there. And now by August 25th, you can tell these are all images pulled off of field view for this grower. And you can see now in 10 days or 20 days, we now have this huge red shape up there, okay? And you can see we went through August 5th through the 25th. Well, like I said, the wedge shapes usually tend to be mechanical issues. Well, the grower actually, the previous two passes, the swing arm got stuck in that corner. So his simple thought was, I'll speed up the swing arm through that part so it doesn't get stuck anymore. He made two passes in that time frame, or sorry, 3 1-inch passes. He sped that machine up to 100%, which the minimum depth was 0.12 inches. So when the rest of the field was getting 3 inches in the month of August, that wedge shape right there, trying to prevent that swing arm from getting stuck, it only received 36 hundredths in the month of August compared to everything else. So uniformity can come in all sorts of ways, not just sprinklers, not just designs, pressures, leaks, that kind of stuff. That uniformity sometimes is how we operate machines as well. So I think that we are to the end. Mike, do we have any more questions?
None that are in the chat. We've got a few minutes, if anybody wants to pop a question in the chat, and I know that we've been good about getting these copied over if you put them in the Q&A.
This is the time. I want to see somebody stump Mike.
That makes two of us, Jake. I don't think it's happened yet.
So yeah, I didn't know we were going to play Stump the Chumps here.
Well, we've got 2 minutes, so.
Lots of thank yous, and we're proud to do this. We're proud to partner with the Irrigation Association and be able to bring you this. We are very happy at Ranky Manufacturing to position ourselves as the irrigation experts, and thankful that the Irrigation Association gave us this opportunity.
I would agree,
Well,
Mike. And for all of those who have ever wondered about more education on any of this, the CID, the CASE programs, those are excellent programs to think about. If you don't think you would ever get certified, even the Principles of Irrigation book is a great book just to have. I think I laugh when I talk to our dealers. I think I have 3 or 4 copies of that one floating around, some in the office, some in my vehicles. I don't go hardly anywhere without those. So
Sadiq
hang on
asked
just
the
a sec.
question, how do
Yep.
you set the boundary while determining the DU? So the boundary, your wet area is going to be defined by what your sprinkler throw is. So when your cups have to start outside those wet areas in order to calculate that DU correctly. So if you've got a throw radius that is short, 12, 15 feet, that's going to change the irrigation boundary you have to use versus a throw of 25 or 30 feet on a different type of device. Your pivot has to start farther away. I saw another one pop up here. How low of a drop can testing be done?
How low of a drop? Oh, well, it depends. Everything always depends, right? And the hard part is because if you get into situations like I'll use parts of Texas, right? And they'll start to do like drag lines. They'll do they'll do um they'll farm in circles and they'll use what's called a dam diker and they'll basically make these little pond reservoirs in the rows of the crop and the pivot walks around and basically it's like a controlled flood, right? But all those devices are sized to put on the right amount of water. That one, if you need to do a field um uniformity test, I would be interested. I know I have a few experts I would make phone calls to. If you guys have those, call your local dealer, your extension offices, right? Ask for those professionals to give you some advice on those.
Awesome. Thanks for that, Jake. And we are at time, and we've got a couple more questions coming in, but I would just reiterate, I dropped my email in the chat if you have any additional questions. I'm sure Mike and Jake would be happy to answer them, and I'll connect you to our professionals here. But again, just want to thank you, Jake. Thank you, Mike, again for your time today and for this very insightful and extremely practical presentation. So thank you again, and good afternoon to everyone. Hope everyone has a great rest of their Thursday and a great weekend. Thanks very much.
Thank you, Luke.
Yep, thank you.